Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Meet you again in the financial data analytics. And for tonight class, we are going to discuss on the financial data analytics using neural networks. The objective that I want you to have for tonight's class is what is neural network and why do we using neural networks? What is the motivation behind conducting neural networks? What is neural networks? What is single layer perceptron? What is multi-layer perceptron? What is neural network implication of use case and the application of neural network and a demo. All right. So why do we need neural networks? There are a lot of problems. Yeah? There are a lot of models that the computer cannot solve that problem. So people, scientists, coming to the cutting edge model where the model can calculate into a more accurate result using the neural network. So the neural network is a predictive model. It has the inputs, the model, and the outputs. This neural network model in the Python is still a black box model. Not so many people understand how the neural network works. But in tonight's class, we are going to learn what happened in the black box. What happened in the black box. In the previous model, when we learn about the regression model, the regression model having some linear line like this, using regression, linear regression. And there is also, we learn about the sigmoid model, logistic regression. 1 and 0. Linear regression, sigmoid model. What is so special about neural network? The model can be bended, like this. The model can be bended like this. If this is the model, you cannot make the model like this. You cannot make the model like this, but the model may be like this. Or even worse, the model can be like this. So the objectives of neural network is to get a model that can be bent anywhere. You can bend it like this and this and this. In order to bend it, you need to develop a cutting edge model where you can bend it anywhere you want. So you can make a model like this. You can make a model like this, anything using neural network. Neural network is a universal approximator that can learn any mapping. And it learn by example. Not only your kid that learning by example. Neural network also learning by example. So he learned about the data and make a model to it. With neural network, nowadays computers can do things that we do not exactly know how to do it. So the model becoming more robust. There will be input, hidden layer, where the layer can be more than one. This one is both is hidden layer and the output. What is the motives behind the neural network? The building block of a neural network is the neuron. The neuron is within your head, within your brain. An artificial neuron works much the same with the biological one does. Almost similar like neuron in our brain. Within the neural network, we are facing with the multi-layer perceptron. As you know, our brain is made up of millions of neurons. So a neural network is really just a composition of perceptron connected in different ways and operating on different activation function. So the activation function, the function is to bend the line. That is the function of the activation function. The objective is for the bending the line. Bending the line. Meow, 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 meow. This is the artificial neural network example. Nowadays, people can conduct face recognition, can conduct clustering with the neural network. My last project was conducting clustering with neural network, a robust model, but it is quite cutting edge, so and not that simple to do it. So there is an input layer, and then going into the hidden layer number 1, and then hidden layer number 2, and then going to the output layer. There are a lot of dimension in the input layer, and then going into the hidden layer 1, hidden layer 2, and then goes to output layer to decide whether this one is your face or his face or that face. So this is what happened in Facebook nowadays. Facebook using neural face recognition using neural network. In when you see the series of Point Break, where the what was the name of the man? So he can he can make a fraud of the face recognition. So this is his face, and then he draw another face in his hand, and then he cover his face like this, and when he draw the eye, the nose, the mouth in the back of his hand, the face recognition recognize that this is the person for the that is allowed to enter the room. So like a Mission Impossible. So that is how to cheat the face recognition. So in conducting neural network, as usual, we need to conduct the
Sorry, Pak Jeffrey.
yes. Come again.
Sorry, Pak. Yeah, but in the previous example with the face recognition, Pak, so with the neural network, can it actually detect whether the person like putting the face on is actually a real person, a real face or not? Or is it just whether the face is similar to the one stored in the database?
Okay. So in the face recognition, you want to check. Let's say the input is the distance between eye, left eye to right eye, left eye to right eye. What is the distance? And then what is the distance between eye to ear? What is the distance from nose to mouth? So the input point is that. So the input point will be the distance. And then the output will be the faces with the highest score. Let's say this one is the face. This one is Giselle. This one is Nining. This one is Carmel. This one is Indah. So there will be score. Giselle is 0.8, 0.5, 0.3, and 0.2. So the highest score is Giselle. So the person is Giselle. The input layer will be detecting the distance, and then this is all the faces, and then which one getting the highest score. So that is the work of the neural network. Araso, Giselle.
Okay, but it won't actually know whether or not like the face is an actual face or a photo, is it, Pak? Or can you also include?
Yeah, that's why the when the prisoner trying to escape, they conduct like that, yeah, in the movie, yeah. So he draw the back of the hand with the police, the authorities face, and then he close his face, and then the door open. So that is on the Point Break movie, yeah. I saw it. So I don't know whether it happened or not, yeah. But that is in the movie, Giselle. He tried to cheat the face recognition model, yeah. So even people want to try to cheat the model, isn't it?
Yes, because like these days when you register yourself to a bank, Pak, let's say, like some banks actually have this technology called the active liveness. So usually you just put your phone in front of your face, right, Pak, and then it matches with, for example, your ID. But now you have to move your head to see if you're an actual moving person instead of a picture. So I'm not too sure if that's actually a part of the neural network.
Yeah, that can be also in the neural network. See, when you move your head, Okay, so what is the changes in the distance? See?
Oh, okay. So you can use neural network for that as well, is it?
Yeah, so the input will be the changes of the distance. So the changes, what is the changes? 1 centimeter, 1 millimeter. Okay, so the changes is correct, something like that. Not only the face, but because if the face only, you can cheat that using the photo,
Yeah.
isn't it? But if you can,
Yes.
if you move, then what is the distance between your neck to the jaws, something like that.
Oh, okay. Understood. Thank you, Pak.
Okay, good. So that is the idea now, because people now can cheat the face recognition, yeah. So okay, when you looking to the right, looking to the left, then the changes is there, like clustering. What the cluster changes. So the distance also changes when you turn right. The distance changes. Yeah. All right.
Yes. Okay. Got
Cool.
it, Pak.
So Pak, the to differentiate from the picture,
Mm-hmm.
for example, the photo and the real face is the jaw.
Not the
Change the
jaw.
jaw.
I mean, a lot of options there. When you move here, and then what is the distance between your ear, yeah,
Yeah.
and your eye? See, what is the
Yeah, yeah, yeah.
distance? So that is the objective of the, because if only seeing into the front, they can only calculate eye to eye, isn't it? But for ear to eye, they need to look at the right side or left side just to calculate. And then the, let's
Oh,
say, the
okay.
ear to the jaw, something like
Yeah,
that.
yeah, yeah, Pak.
So they need to also calculate that. So to identify whether this is the right person. Yeah. But if using the picture, you cannot. If you change that, no,
Yeah,
you
yeah.
cannot see, isn't it?
Okay, okay.
Okay, got it.
Yeah, Pak.
So there is a sensor, the data sensor, the IoT, sensoring the face, yeah, calculating the distance using the sensor. Then the IoT data going into the neural network model. So there is the input there, and then going to the model, and then what is the result? Is it Giselle or is it Yolanda? Based on the distance. All right. Okay, let's start on the process for neural network. As usual, let's say I'm using the data from the materials, yeah. So the data is vary, yeah? Some data is high, some data is low. Therefore, we need to do the data normalization. As usual, the data normalization can be separated in min-max normalization, yeah, or standard scalar. Yeah, standard scalar. Yeah, supposedly you all understand that. We did it and in many projects before. And then there are two options in the neural network. Among a lot of model, yeah, the neural network is quite vary, yeah. Many options in neural network. Some is there for the regression. Okay, so when we conduct neural network for regression, okay, we conduct neural network on top of we conduct regression on top of neural network. So the model is like this. There is input and there is output and there is black box. So let's say we have the data input here. Melt temperature, electric resistivity. And then this is the hidden layer. Yeah? To calculate the modulus, the output layer. So let's say the hidden layer is A1 and A2. There is melt temperature and electricity resistivity that is influencing the A1. So there will be weight there, weight 1 and weight 2, towards the hidden layer of A1. And also there is, for the A2, there is weight 3 and weight 4 towards the A2. So the activation, the one that is for the bending, for the bending is A1 equal to, is the function of weight 1 times the melt temperature plus weight 2 times the electric resistivity, plus B1 bias, bias, or in regression it's constanta, the bias. And then for the A2, the activation function is W sub of 3 times melt temperature plus W sub 4 times electric resistivity plus B2 as the constanta. Therefore, the Young modulus is equal of the function of W sub 5 times dA1 plus W sub 6 times dA2 plus the B sub 3. This is the model prediction for the regression. Remember, the regression is for the interval. So far so good. Araso. Araso.
Still trying, Pak.
Still trying. Okay. All right. No worries. And then let's continue. So those are using forward propagation. Those are using forward propagation. So the melt temperature influence the A1 and A2, and then this is going into the Young modulus. That is what we call forward propagation. The bending can using the linear, which is fx equal to x, or sigmoid using tangent with the function of x, or ReLU, reactivate. What is ReLU? Wait a second. I recall. Wait a second. What is ReLU? ReLU. Wait a second. ReLU activation. Reactivated linear unit. Linear unit. Okay. Reactivated linear unit. Okay. The most common activation function for bending, for bending the line is ReLU, the most advanced one, because it can do like this. Like this. So he can this one he bend, this one he bend, this one he bend. If tangent, if sigmoid, they only like this, sigmoid. One, 0 and 1. Linear going up there, yeah, unstoppable. While the data maybe want the model like this. So ReLU is the highest request one for the neural network. Reactivate linear unit. All right. Wait a second. So when the in the forward propagation, this is the same, yeah. W1 times melt time plus W2 times electric resistivity plus bias equal to A1. Yeah, A2, and then Y, the Young modulus, is the function of W5 times A1 plus W6 times A2 equal to B. Using the ReLU. And then the beauty of neural network, there is also back propagation. Yeah. Why do we need back propagation? So there is a testing and training, yeah, a training and testing. In training, there is, let's say, the number is, let's say, this is the actual and predict. If it is actual is 0 and it predicts 1, then it will go back, yeah, go back and then change the weight, 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 change the weight. It will go back, yeah. Depend on how many times you want it to do the trial iteration. In the back propagation, the changes can be done in the weight for the back propagation until the result is correct. How do you know when do we need to conduct back propagation? How do we know we need to change the weight? By the mean square error. If the mean square error is high, meaning there is still some iteration needs to be done to ensure the accuracy is high. Also using the mean absolute error, mean square error, and the mean absolute error. If it is high, then we need to conduct some back propagation. So this is how the black box work in the neural network with regression. Any questions? Neural network with regression. Any questions? Arasso? Capish?
Actually, what is F1 in here?
Which one? Irwan?
F1.
F1? Which F1? F1.
In the
function.
function.
Function 1, function 2. So this is the activation function.
And then W is weight, right?
Yes, the weight, the coefficient, the weight. Yeah. Okay.
Oh, so bias is the constant.
Yeah, almost the same like constanta plus the constanta. That is how we interpret, yeah, like a constanta. While we call it in the neural network, we call it bias. Okay, so when we do back propagation, when the desired output is not the same, then it goes back. Yeah, it goes back, and then checking the absolute error, checking the square error, if it is still high, and then we change the weight as well. We change the weight 3, weight 4, we change it until it is all coming into the high accuracy model. Change the weight, change the weight, change the weight. We can increase the weight, decrease the weight when it, to reduce the error. Okay. So the neural network visualization can be accordingly with the coordinates. Sometimes when the coordinate is like this, linear regression cannot do like this. Sigmoid cannot do like this. We can only try to make the line as precise as possible, the model as precise as possible. So the model learn about the data using the bending. So we need to bend the line here using the activation function. Using the ReLU. Not linear, not sigmoid, but ReLU. Reactivated linear unit. Yeah. Next is neural network for classification. Yeah. We learn about regression. Mostly, the neural network is solving classification problem. When we do the clustering model, there is classification. Yeah. So in neural network, we predict for the classification, we predict discrete categories. So let's say we predict, let's say in the Irish data, so we predict the type of flower. Is it Sentosa, Virginia? Yeah. Given all the data, this is the heat information. Okay. This is the heat information, the lattice constanta, the melting point, the specific heat, the atomic mass, the atomic radius, the electricity relativity. We need to identify the FCC, BCC, HCP, and there's only 3. 1, 2, 3, yeah? What is FCC? FCC, yeah, this is the chemical name, yeah? Chemical name. So, and the encode will be like dummy variable. So when it is FCC, then 100. BCC 010. HSP 001. Yeah, because there is three output. Yeah? 3 output, 0, 1, and 2 on the array. Yeah. So in creating neural network for classification, yeah, we do it like we do it using the what we call is softmax. There is options there, softmax and arcmax. Yeah. So, but mostly in the neural network for classification, we do it using softmax. Yeah. Softmax activation allows interpretation of output as probabilities. So the same like multinomial. Okay. So softmax activation function is E of the Z E divided by okay. Let's say E01 divided by E01 plus E02 plus E03. Yeah. So this one, that's the function. E01 divided by, this is the y, divided by E01, 02, 03. Expects, this is the exponential of 01 divided by exponential of 01, 02, and 03. Remember, in the logistic regression, we learned 1 plus exponential by the power of minus from C plus beta x blah blah blah. So this one is like that. Exponential, yeah, of 01 divided by exponential of 01 and exponential of 02 and exponential of 03. Yeah. So when the output like this, 0.65, 0.25, 0.10, the classification is 0.5 because the score is the highest. Yeah. So this is how we decide the classification using the neural network. Okay. The accuracy in the neural network for classification, we use the number of correct prediction divided by number of prediction. What is the accuracy? Yeah. And then in the neural network for classification, we also learn about backpropagation. If the result supposedly 01, then we change the weight as well. So we change again this weight, and the weight. So accordingly, until the result is the same, the accuracy is high. So the backpropagation also by changing the weight, the coefficient, depend on the iteration that we use. And the objective function is categorical cross entropy. So the cross entropy is, wait a second, cross entropy, I know it, but the definition is quite tricky. Wait a second. Cross entropy. Okay. The measure of the difference between two probability distribution for the given random variable of set events. Yeah. Okay. Entropy. Cost entropy is the average number of bits used for information. Okay. So we need to ensure in the neural network for classification that the cross entropy score is high. Yeah, it means that the difference between two distribution is high. Yeah, the difference. So we need to ensure the cross entropy is high. It is one of the critical point in the neural network classification. So in the neural network for classification, there is cross entropy, back propagation, yeah, and then using the softmax, yeah, softmax. Okay. When the result of there is some issues also regarding overfitting and underfitting on the neural networks. Underfitting, yeah? The model has not learned all the trend in the training data, meaning underfitting. The training data is high, and the training data accuracy is high. Okay, this one is accuracy. The training data accuracy is high, and the testing, this is the training, this is the testing, accuracy is high, and then, is low, and the testing data is high. This is what we call underfitting. When the training accuracy is low and the testing accuracy is high, it is underfitting. Overfitting, when the training data accuracy is high and the testing accuracy is lower than the training. That is what we call overfitting. Adding more layers to our network can result in overfitting. When you conduct the hidden layer, when you do hidden layer with plenty of hidden layer, 1, 2, 3, 4, and then this is the input, this is the output, the more layer it can result to, too much layer can result into overfitting. What is overfitting? When the training data is high accuracy and the testing data is lower accuracy than the training data. That is what we call overfitting. Yeah. And in the neural network for classification, when you only have 2 targets, you can use sigmoid if only 2 targets. But if it is more than 2, or meaning 3 and above, you need to use softmax. And the loss function, if only in binary, you use mean square error or binary cross entropy. While in the more than 2 or 3 and above, you need to use sparse categorical entropy in the Python. So the process will be in the neural network. You start and then read the dataset, define features and labels, and then divide the dataset into training and testing. After that, the TensorFlow or Keras platform, yeah, develop the structure and then implement the model, train the model. If the mean square error is high, then you need to retrain the model, yeah, until it is robust. Then you can use the model to make prediction on the data test. And the application of neural network, it's plenty. Yeah, it's plenty. In medicine, on the doses of vaccine, is it low doses? What is the result? Medium doses? What is the result? High doses? What is the result? And mostly using the neural network. In the marketing, in the business, credit evaluation, neural network also being one of the cutting edge model, yeah, because the high accuracy that he offered. All right. Any questions before we go to the Kaggle? Araso? Okay. Getting more headache. Good. Okay, neural networks. Okay. So here we are in the Kaggle. Let me share. Private, public, save. So in the neural network for classification using iris data, I use the iris data set. As usual, we import NumPy, Pandas, Matplotlib, scikit-learn. Yeah. And then after that, the iris data. We create the train data and testing data. So the data frame is in the iris data of the iris feature names, and then the iris target, we change the name into flower. Yeah. And then the data head, the data is like this. Let me run first. Okay. Is it running yet? Okay. This one running. Okay. So this is the, in the iris there is the sepal length, sepal width, petal length, petal width, and the flower name. The flower name, there is 0 is Sentosa, 1 is Virginia, number 2 is, what is it? I forgot. The flower name there will be 3 name of the 3 flower name. We want to determine, we want to make a model. If the sepal length is within this centimeter, the sepal width is with this centimeter, the petal length is this centimeter, and the petal width is this centimeter, what is the flower name? Let me check like this. Okay, iris data kah? Iris neural network, Python, image, iris. This one. Okay, the name is Setosa Virginica and versicolor. We want to identify if you put the length of the sepal length, sepal width, petal length, petal width, what is the flower name? Is it Setosa? Is it Virginica? Or is it versicolor? That is the objective of the model like this. So when you have the length, the measure of sepal and petal length and width, you want to determine what is the flower name. Is it Setosa, versicolor, or Virginica? This is the model. Okay. And then, all right. So we have the flower name unique, 0, 1, and 2. And then,
Pak Jerry?
yes.
Sorry, Pak, but the question is like the concept one. So hidden layer, is it always 2 or can be more than 2, Pak?
Can be more than 2. Can be lot of hidden layer.
Is there any minimum for the hidden layer?
No, nothing.
Because
So,
the picture always show.
You can do 3 layer, 4 layer, 5 layer, depend on your wildest imagination. But the risk will be overfitting and underfitting. That's all. But that is okay. Yeah, we can develop what we call that, as many layer as you want. Yeah. Okay. So from scikit-learn, okay. So as usual, the first thing first, normalization. From scikit-learn pre-processing, we import standard scalar, and then the SS is the standard scalar, and then we fit on the iris data, the standard scalar, and let's see the result. Okay, right, and then from scikit-learn model selection, we import train test split, and there is train input, train output, test output. Yeah. After that, after we set up the train and test split data, we have the data with the standard scalar, and then we import. So in the neural network, the platform we call Keras. This is the platform of neural network, what we call it Keras. There are also TensorFlow for the neural network. So, but I do not use the TensorFlow here. So I use the Keras, yeah. I use the Keras. So in the Keras, we import sequential, dense, and dropout. Okay. All right. So we name the sequential as model. And then we add one layer, which is using ReLU activation. We develop one layer with 5 nodes. And then we create another layer with ReLU, 100 nodes in one layer. 100 nodes in one layer. And then I use 3 layer, multi-layer perceptron. The node is 20 on the third layer. And the activation function using ReLU. And dropout will be 0.1. And this is the output using 0, 1, 2 on the unique flower using 0, 1, 2, and the activation using softmax. So in the output, the activation function is using softmax, but in the nodes using the ReLU. And then for the loss, we add model, compile, loss, sparse, categorical, cross entropy, because it is more than 3 layer. Yeah, sparse, categorical, entropy using the more than 3 layer with the matrix equal to accuracy. All right. And then let's run the model with the iteration 100, the bit size 30. Okay. So the model runs. So we see the accuracy is 0.44. So the model keep running, calculating the weight. So increase 0.75, increase 86%, increase 92%. So the model learn about the data and then increase the accuracy, changing the weight, yeah, changing the weight until 100 times. And then we get the accuracy of 96%, quite high. And finally, we evaluate the model of the test input and test output. The accuracy is 97. So if the training data is 96%, and the testing data 97%, it is a little bit underfitting or overfitting? Under or overfitting? When the training is lower than the testing, it is underfitting. Yeah, just a little bit, no worries. But the percentage is quite robust. So this is how the neural network develop the model. Yeah, the first model, when they run, it is with the forward propagation only 44% accuracy, and then back propagation, forward propagation, back propagation, forward propagation 100 times until the accuracy is within the 100 trial. We got the accuracy 96%. You can increase to 200 if you still want to get it 100% accuracy. You can do it, but you need to change the epochs. So this is how the neural network work. Any questions on the neural network? So far so good. Arasa?
Jerry?
Yes, Giselle.
So just now there was like a 1% difference between the accuracy of the testing and the training data, right, Pak?
Yep.
Is there any like rule of thumb for the difference for it to be considered okay? Like for example, like maximum 5% up, bigger than 5% difference, then you have to repeat the model or the training.
So it depends on the project, yeah. So if it is regarding the let's say if it is regarding the consumer behavior, usually it is 70 to 80 still okay. But if it is into risk management, they are usually request above 90%. Yeah? 95 is even better because this is about risk. Let's say credit scoring, yeah, or credit rating. So they need with the highest possible accuracy. Yeah? But mostly in the risk is above 90 is considered okay. In the consumer behavior, 70 to 80. In marketing, 80 to 90%. In marketing.
So,
yes.
Even if the model is like underfitting or overfitting, as long as both are still in the range, it's still okay.
Yeah, meaning if it is, let's say it is 90%, but the testing data is 85%. So it is not within the appetite of the credit scoring, because credit scoring requests above 90% for both training and testing. But also depend on the appetite as for the high level management. He can set the threshold will be 95%. So you need to conduct the neural network to get training and testing above 95%. But if the training is 95, the testing 91, so that will be problem, isn't it? Because below the threshold of the high level management.
Okay, got it, Pak.
Okay.
And sorry, Pak, can you repeat the part about the changing the epochs, Pak, to make the accuracy higher?
So if you consider the model is not within your expectation, you can change the epochs from 100. You want to do the iteration 200 or 1000. So it will consume, let's say, 1 day. Let's say you put 10,000 times, something like that. So you want to have a very accurate model. depend on the iteration. So when the back propagation and forward propagation, back propagation and forward propagation, to get the with the highest model accuracy.
Okay, get it, Pak.
All
And
right.
I think this Kaggle has a capacity limit, right, Pak? Because it's free. Like how many iteration can it handle?
I don't know if doing neural network. Usually, I use Jupyter notebooks.
Oh, okay, Pak.
Yeah, because
Is it because it's longer?
because
Yeah.
the platform capacity is not for the um, I haven't tested for the millions of data yet, yeah, but uh, because this is under the SaaS, yeah, a software as a service, yeah, software as a service, or PaaS, platform as a service. So the limit, there supposedly there is a limit, not for the extreme big data.
Okay, got it, Pak. Thank you, Pak
Okay,
Jerry.
all right. Anyone else to ask questions? No? So far so good, Araso?
Pak Jerry,
Yes, Yolanda?
sorry, I'm missing your explanation about ReLU.
Relu, okay. Relu is, okay. The key for, okay. Okay, let me open another. Okay, all right, okay. Okay, when there is, okay, and then this is the input, this is the output, this is the hidden layer. Okay, ReLU. So for linear data like this is using linear. For sigmoid data like this is using sigmoid. But if the data is like this, the model is like this, you cannot do linear because it will not be able to follow the line. Sigmoid cannot follow the line. So we need to bend the line. When the line is like this, we bend it going like that. We bend it going like that. We bend it going like that. So that's where ReLU works. ReLU is the reactivated linear unit. Reactivated linear unit. Yeah. The ReLU model.
Okay, Pak.
Got it?
Ya, Pak.
So,
Okay, thank you.
the bending master, not the Tai Chi master, the bending master. That is what ReLU is. Araso?
Ya, Pak.
Okay. Any other question? No questions. All right. If no questions, I want to discuss regarding the final exam.